This is a recording for math analysis, and we're still working on section 2.1. Oh, I forgot. And this is section 2.1, part 2. And we're continuing to look at power and radical functions as we go. And last time I left off by asking you to complete 1B. And so let's look at just how things went. First, I'm just going to reveal the answers here. So you should have graphed y equals negative x to the 5th power, and probably using that caret key. And you should have a graph of that. It looks kind of like this. And our domain, so if we walk along the x-axis from negative infinity to infinity, it hits we find it everywhere. And so it's negative infinity to infinity, the range negative infinity to infinity. The x-intercept and y-intercept is just at one place. That's at 0. The limit of f of x as x goes to negative infinity is going to be positive infinity. So as x goes to negative infinity, y is going to positive infinity. And the limit of f of x as x goes to positive infinity, as we walk out that way to positive infinity, y is going to negative infinity. And then we were asked to comment on the continuity. If I try to drag my cursor along this function, I can kind of see the whole thing. I don't have to pick it up. So it's continuous over its whole domain, or for all real numbers. It happens to be decreasing. Now, it looks like it's flat here near the origin, but it is still always decreasing. So look at your calculator and kind of see what those look at like. But it's decreasing quickly, and then slower, 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 and then it hits 0, 0, and then it's still decreasing, but slowly, but then it starts picking up speed and decreases faster and faster. So it's decreasing in the interval from negative infinity to positive infinity. And there is an error on the slide there. Okay, and I corrected that. It's decreasing from negative infinity to positive infinity, always decreasing as we go. So now we're going to look at just some more of these as we go, and looking at negative exponents. So remember, and this is something you might want to make note of in your own notes, that if f of x equals 1 over x, that is the same as f of x equals x to the negative 1. And it is undefined at x equals 0. And so if we have x to the negative 2, x to the negative 3, that's 1 over x squared, 1 over x to the third. Those are also all undefined when x is 0. And because power functions can be undefined when n is less than 0, the graph of these functions will contain discontinuities. So if we're raising x to a negative power, we're going to have discontinuities as we look at that. So again, we're just kind of looking at more of these graphs. If we were together, we would look at them together. So this is 2a, and our function is f of x equals 2x to the negative 4. We want to describe the domain, range, intercepts, and behavior continuity where the function is increasing or decreasing. Go ahead and pause this. Oh, before you pause it, sorry. Just keep in mind that that can also be written as 2 times 1 over x to the 4th, or 2 over 1 times x, 1 over x to the 4th. So a lot of times we'll see that as 2 over x to the 4th. So these are the same function as we look at that. But certainly you can type it in your calculator as 2 times x to the raised to the negative 4 power. But just know when you see this, it's going to have that negative exponent. Now pause this, see if you can answer all of those. If we were in class, I would actually have you graph it, show me the graph, and then answer all those, and then I would call on people. But here I sit, and You have to just do it, and I have to expect that you're doing it. So pause this. Now, moving along, let's see what we have for this one. And sometimes my pictures are not great from the book authors, but I think this one's okay. It's not my favorite because I don't feel like it looks like it's quite as symmetric in here as I feel like it would be or is on your calculator. But as we look at that, then you should describe all these things, the domain from negative infinity to positive infinity. Yes, 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 yes. It's getting super high here, but then when we step on 0, because remember it's like 1 over or 2 over 0, then that's going to be undefined. So there's going to be an asymptote along there. It's undefined. It has infinite discontinuity because it's going to positive infinity on both sides. Could go positive or negative. But then as we go on, it is defined all the rest of the places as well. So our domain is from negative infinity to 0, union with 0 to infinity. But now let's think range. Range, we come from negative infinity. And I'm looking to the left and to the right to see if I see anything. Nothing, 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 nothing. And actually, when I step on that, I still see nothing. Those are super close, but they actually don't go down to the axis. And then I look left and right. Oh, yes, 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 yes. I see it everywhere on the left and the right. And so it's going to start here just past 0. So 0 is going to be the end point with a parenthesis. And then it's going to go to positive infinity for that one. And so our domain, there we go. Oops. Our range, excuse me, is from 0 to infinity. The limit of f of x as x goes to negative infinity. So as x goes to negative infinity, what's happening to y? It's also going very close to that axis. And so it is getting closer and closer to 0, but it will never hit 0 as we look at that. So let's get rid of, oops, that stuff. And so that means the limit of f of x as x goes to negative infinity is 0. Same thing happens out on this other end. As x goes to positive infinity, what's happening to y? It's getting closer and closer to 0 as well, and never actually reaches there. The next thing we have to talk about is continuity, and we already said it's discontinuous here, and it would have an asymptote, or it does have an asymptote here. It's not drawn in on the axis, but there would be an asymptote there. And we also talked about, if you remember how to find that, we're when we're looking at this, we're saying as it gets close to 0 from the negative side, it's going to positive infinity. As it gets close to the 0 from the positive side, maybe I said positive side before, negative side, positive side, it's also going to positive infinity. So that is infinite discontinuity, and it has infinite discontinuity at x equals 0. And then decreasing and increasing. So if I'm going from negative infinity and I'm going along here, it doesn't seem like it's increasing, but it is getting a little bigger and bigger. And then it's increasing until we get to 0. So from negative infinity to 0, it's increasing. And then as soon as we hop over that 0, it's super high and it's coming down, 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 down. And it continues to decrease as we look at that. So that means that it is increasing from negative infinity to 0, and it is decreasing from 0 to positive infinity. And those intervals always use parentheses. We don't really use an endpoint as we do that. So here's the next one. I'm just going to say pause this, do that problem, and see what you get. Okay, let's move along and look at that. So make sure you've labeled that this is 2b, and so this is f of x equals 2x to the negative 3. And in your mind, just remember that's f of x equals 2 over x to the third. So it is this kind of reciprocal function with a negative exponent. When you graph that, it should look kind of like this. Our domain is from negative infinity to 0, union with 0 to infinity. Our range this time is the same. Notice in that other one, they were both kind of flipped up. Now we're taking this left side and flipping it down. So we have the same thing for the range as the domain. From negative infinity to 0, union with 0 to infinity, where there's no value for either x equals 0 or y equals 0. Even though it's negative as x goes to negative infinity, it's still getting closer and closer to 0. So the limit of f of x as x goes to negative infinity is 0. The limit of f of x as x goes to positive infinity is 0. It is discontinuous again. And even though this one goes to positive infinity, that one goes to negative infinity, it's still infinite discontinuity. Your three types of discontinuity are infinite discontinuity, which this is, and the last one was jump discontinuity, where it jumps from one thing to another. This, you might think of this as jump, but since it's going to infinity, positive or negative, that's why we use that. And then the other one is removable discontinuity, where it appears as though it's a smooth curve, but it has a value that it's undefined at. So this has infinite discontinuity at x equals 0. It is decreasing on its whole domain, so it's decreasing from negative infinity to 0 and from 0 to infinity. Now, pause this if you need to write some more down, but we're going to go on to the next part, and that is when we have x raised to a fractional power. And so just a reminder to ourselves that if we have, the square root of x, that's equal to x to the 1/2. So when we have a fractional power, that's going to be that root. So if we have the cube root of x, that's x to the 1/3. If we have the cube root of x to the 4th, that's x to the 4/3 if we write it as a fraction. So x to the 1 over n indicates the nth root of x, and x to the p over n, where p over n is in simplest form, indicates the nth root of x to the p. If n is even, then the domain has to be restricted to non-negative integers. And so remember that, because look at, think about this. This is an even 1/2, 2 is even. And if we have the square root of -4, that is undefined. In the real numbers, of course, yes, we could use I and all that, but we're staying within the real numbers when we graph things, because then we can kind of see them on the graph. So take a minute. This is now 3a. And it's f of x equals x to the 5/4. Good thing to practice on your calculator, because we're not used to really using rational exponents very often. And so try typing that in and graphing it. And if you want to answer these questions, go ahead, and then I'll go over them. Okay, moving along, our graph should look like this. F of x, oh, just kidding. Let me go back over this one in just a second here. Oh, wait a minute, wait a minute, wait a minute, wait a minute. I forgot that I have the graphing calculator here, so let me put that on. And so we're at ny equals, and it's going to be x raised to the, and if you have a newer calculator where it gives that little box, you don't have to put it in parentheses, but this is 5 divided by 4, and then I think it's going to be a standard viewing window. It kind of looks like this when we look at that, and so a little kind of hard to see if we look at a table of values. Second table set. Let's start at like -1, and I'm actually going to go by 0.1 just to kind of see what's happening there as we go. And let's look at a table of values. So notice that it has an error message for all of those. And then as we arrow down and get closer, at 0, it's 0. And then we get values for that as we go. So that is what our graph looks like. And now, there we go. Now that we've seen that, and it just looks a little funny to me on there, but that's okay. Let's say what the domain and the range and all those things are. It doesn't really have that asymptote. It's just not defined beyond x equals 0 or y equals 0. So our domain is from 0 to infinity, including 0. Our range is from 0 to infinity, including 0. The intercept is 0, 0, or the x-intercept and the y-intercept. Notice we only have one limit because this does not go to negative infinity. So we don't look at left end behavior. We only look at right end behavior. And if this goes to infinity, y is going to positive infinity as well. So the limit of f of x as the limit of f of x as x goes to infinity is infinity. And then continuity, this actually is continuous on its whole domain. I can trace it along there and it all works out just great. So it's continuous on the interval from 0 to infinity. And lastly, increasing, decreasing, or 0, it's increasing along that whole domain. Remember, those intervals are always with a parenthesis on them as well. Our next problem is 3b. And so that one is a little hard to read. I'm just going to write it here. This is 3b. And it is f of x equals 4x to the -2/5. And so be careful when you do that one. Go ahead and see what happens there. And then we'll look at that at our next, or after you've paused this, and we'll kind of see what happens there. So pause this, see what you get. Okay, let's look at that. Our graph for this one looks kind of like this. And then sometimes, not a super great graph, but that's okay. And our domain, it has that asymptote at 0. So our domain is from parentheses, negative infinity to 0, parentheses, union with 0 to infinity, not including 0. Our range, notice, and it looks a little high there, but that's okay because we have that fifth power there as we look at that. And so then the range is from 0 to infinity, not including the 0. This does have left and right end behavior as x goes to negative infinity. Notice this is getting closer and closer to 0 as we go. As this goes to positive infinity, x goes to positive infinity, the limit of f of x as x goes to positive infinity is also 0. Continuity, we can trace it like this, but then we have to pick up our pen, so to speak, and then we can trace it again. It is not continuous like this. It doesn't have a maximum there. It has an asymptote and it's undefined. So our continuity is it has infinite discontinuity at x equals 0. It's increasing from negative infinity to 0, and then it's decreasing from 0 to infinity. And again, parentheses for those intervals as we go. So the next thing we have to do, and we're going to do this in the next lesson, but I'm going to have you get set up in this lesson. And so what you need to do is you need to make a scatter plot of this data. And it says this is 4A. And so you should write down this table of values. It says the following data represent the body length L in centimeters and mass M in kilograms of several African golden cats being studied by a scientist. Create a scatter plot of the data. So this is X. This is Y, and you're going to create a scatter plot. And so please write this down because you're also going to put it in your calculator. And when you do this X and Y, notice that lengths X are kind of go from 72 to 91. And so instead of going from 0 to 100, because it would be hard to put all that there, and you'll notice these aren't varying that much, let's do that little kind of crinkle in our graph and go from 70 to 90. And you can decide how far out that goes. I'll leave that to you. Or you might even go to 100 or 70, 80, 90, 100, you know, if you want to kind of just see a little further. And then the mass goes from 11 to 18. So, you know, that's only to 20. You can go from 0 to 20 if you want, or you might put that little crinkle thing there and maybe go from 10 to 20, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, maybe I would go 10 to 20 because that still gives you that many. So make a scatter plot of that for the next lesson, and we'll kind of see how that went. If you want to put these in list 1 and list 2, that will be helpful as well. If you noticed, I have a graphing calculator now, so I'll be using that in this next part of the lesson. So this concludes part 2.